Give me a break here, man. Come on.
Get this show on the road. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 275, Mud Pulse Telemetry, 3D printed gears in detail, and display hacking in our future. This week in the news, Raspberry Pi goes public. If you were clicking on the London Stock Exchange website over and over again to see when Raspberry Pi finally showed up, it finally happened, I guess it was Monday last week? We'd heard rumors of their IPO for a few months, and it looks like it's finally happened. 39 pound cents, which I guess are called pence, a share will get you a share of Raspberry Pi Holdings, PLC.
Yeah, I mean, I feel like we've been talking about this so long. Part of me thought it already happened, I guess. Because we've definitely done like several articles on this. Jenny's been on top of this, like you said, for months now. It was all when I saw the headlines, I was almost like, wait, I thought we did that already. Like, were they not already? But no, it's like now it's official. Everybody seems not super happy in the comments about it, I gotta say. I didn't see a lot of positive sentiment.
The comments are off the rail negative about capitalism in general, and I think are full of misunderstandings. And I'm sorry, I don't mean to call y'all out, but my God. So I dug into this a little bit, and the way that Raspberry Pi has been run since forever, actually, is the nonprofit part, the Raspberry Pi Foundation, spun off and wholly owned the Raspberry Pi Limited, which was the part that actually did the money stuff, made the computers, sold them, and did the marketing there. Whereas the Pi Foundation is basically makes educational stuff and tries to get computers into schools and in the hands of students. It's a real legit nonprofit charity. And this is apparently a normal thing to do in the UK. If there's a businessy aspect to a charity, it lets the charity earn money through this one part of the company, support itself by owning kind of a company that then makes money to be funneled into the charity. And that's the way it's been working since forever. They've spun it off now, right? And so the Raspberry Pi Limited is now Raspberry Pi Holdings, PLC, and you can buy shares in it. And the foundation still owns it. And in fact, what happened here is the foundation sold a bunch of its shares. They were saying that the foundation still owns 70% of the stock, although I'm not 100% sure of this. But they basically made a crap ton of money for the charity slash nonprofit part by selling the stock off. And now they've got a big old fat endowment with which to keep doing their public good stuff. So I think that's really cool, actually. Whether this will change the business going on with the Raspberry Pi making, who knows, right? The foundation's still the majority shareholder. So they kind of have to do what the foundation tells them to do. There were some people in the comments saying, now they have a profit motive, they'll something. But I don't think they have any more or less of a profit motive than they had before. And their profit motive was to make more money so they could give it to the charity. Like, that's actually the goal of Raspberry Pi Limited. So, I don't know.
A lot of the commenters said, they're moving away from the makers and they're going on a more corporate route or whatever. But like, it was never really about makers. We just sort of co-opted it. It was always about being an educational computer that was cheap enough that you could give away, right? Like, we saw, oh wow, cheap Linux computer with GPIO. We could do stuff with that and kind of ran with it, but it was never really meant for us. So I always thought this was kind of weird where there's this feeling in the community that the Raspberry Pi Foundation like owes us something, like they've always been pretty clear about what they're trying to do, and they're just continuing to do that. And undoubtedly, it's been a boon for them to have hackers and makers buying these things, right? But it was just like a nice side effect. I think it was never the goal. It was not made for us. We just saw it as an opportunity.
When we were pushing Eben Upton about this in an interview with Floss Weekly, he ended up saying, look, I started this whole thing trying to make computers cheap and ubiquitous and get Linux into the hands of school kids everywhere. And that's how I started it. And that's what I'm still doing. And anyone who doubts that can just, wait 10 years and see how it turns out. And now that it's happened, I think that's where we're at. I think we're at the no more time for guessing what's going to happen. It's just now the wait and see time.
This is a journey into sound.
What's that sound?
What's that sound?
All right, well, let's head on off to What's That Sound? This week is a Guess the Sound week, which means you listeners and special guest Tom Nardi get to listen to the sound, guess what it is. The difference, of course, is that you will be eligible to enter your guess and hope to win a Hackaday podcast t-shirt if you get it right, whereas Tom, just gets fame and fortune.
Yeah, right. I'm starting to think, what's that, like face blindness, where you can look at somebody but you don't recognize them? I think I have that, but for sound. I have sound blindness. Like, I can hear them, but I can't identify them.
It's hard.
Let me listen to this one. Oh, come on. What the hell is it? Like, I recognize it, but I just can't. Especially that.
You could blame Christina Panos for this one, by the way. She sent this one in.
I mean, it's certainly some game thing of an age.
Yep.
Game thing
exactly.
Of a certain age.
Correct.
Is it an arcade?
It is?
It is an arcade. Oh, man. Why can I not? It's not.
Ba-da-da-da! Congratulations, Tom Nardi.
Oh, there we go. Oh, man.
There you go. Good job.
I instantly remembered, it unlocked like a core memory, but I having trouble drawing the connections.
I had to let that one percolate long enough, and it'll come up.
There we go.
Well, congratulations, Tom. The rest of you head on over to hackaday.com/podcast. Scroll on down to What's That Sound, click on the form, enter your handle and your best guess, and if you get it right, we'll put you in the drawing to get a Hackaday podcast t-shirt next week.
I think we'll get a lot of ones for this.
Last week, we were looking at a hack from Marco Reps, who's a little bit of a volt nut, and it was how to make a switch that is all copper so that it didn't have any temperature sensitive thermocouple-like junctions in it that would introduce like nanovolts of imprecision into his measurements. Reflecting on that, I realized that what I really liked about that problem was not his solution to it, although it was totally awesome, but what I really liked most about that was like the problem itself was a crazy and interesting problem. You could just kind of spin your mind around for a little bit. And that is the case with this hack, but in spades. This is bidirectional data transfer through mud. This is a review article, an academic review paper by Saleh Mwachaka, Aiping Wu, and Qingqing Fu. It is about mud pulse telemetry. And you're all saying, what? But here's the problem, and it's a really interesting problem. If you're drilling a really deep well, like for oil or whatever, kilometers deep into the ground, you want to know like the temperature, the pressure, radiation, speed of rotation, all sorts of information about what's going on at the drill head way down there, but you're stuck up at the surface. How do you transmit this up? They've tried all sorts of things, including but not limited to direct electrical and electromagnetic transmission, but the borehole is filled with a mud fluid, basically. And you could think of it as being a tube with a slightly wider than the tube drill head at the bottom. And so then there's all this kind of extra space there, and they fill it, they pump pressurized mud through there, both to kind of excavate out the junk that they're drilling up at the time, but also to keep everything cool. And mud pulse telemetry is modulating the pressure waves in this mud that goes back up to send signals from the drill head. If you haven't read the article, take a wild guess at what kind of baud rates they're getting out of this. 6 kilometers underground by modulating the amount of mud flowing through this crazy pipe? The answer is kind of in the 2 to 10, maybe the highest baud rate systems are kind of up around 20 baud. And so there's not much data you can get out of this. And the reason is it's just an incredibly difficult problem. And so the paper goes into the kind of 3 ways that they do this. The first 2 are basically by opening and closing a valve. And so you either let more mud slip through or you push some extra mud through with kind of a secondary little pump. And the third one is called the siren, which is my favorite of them, which is letting more and less mud go through. So you're making kind of a sinusoidal pressure wave in there, and then opening and closing the veins on this. So you're actually doing amplitude modulation on the carrier of varying mud pressure. That's the craziest thing I've ever heard. So the paper takes this as kind of a signal processing challenge and looks at what the different sources of noise are, which include, mud isn't just mud, and the pressure wave like disperses as it moves up the mud. There can be more or less air in the line, more or less gas, more or less rock that changes the transmission characteristics all the time. Well, I mean, there's the pump that's pumping this mud through the system. It's got to have its own kind of noise. And so then they look at all the kind of frequency domain ways you can filter this noise out and try to recover the signal from this weird signal. Anyway, really, really, really neat research paper, because it just opened my eyes to something I'd never even thought about before.
When I first read this, I immediately wow, this is like a Dan Maloney thing. So I liked when we did our weekly call, and Dan was like a little upset that that he didn't get dibs on this, because he's kind of the resident, like, here's a weird thing that your life depends on in a way, but you didn't know about it, right? Because as we saw in the comments, the people who work in the oil field, and this is something they deal with daily that none of us have ever come across, right? Unless you have a borehole in your backyard that you've been working on. This is just well outside of our wheelhouse, but fascinating stuff. To me, I think the most interesting part, and possibly I've misunderstood this entirely, but when they're drilling these things, they're just sections of pipe, right? So like you go as far as you can, and then you just put like another section of pipe on, and put another section. That's how you get farther and farther down. So like there's no wires or anything, right? So they needed to use the medium to transmit, but that also means there's no power. Yeah, is it like powered or
running on a battery? Maybe,
but then like you're not pulling it up to charge it, like once it's down there, it's down there.
Right.
So
yeah.
Like I said, unless I'm wholly misunderstanding it, and I'm sure someone will be happy to correct me.
That's funny. This whole article is all about the data transmission and the the signals problem here, and not at all about what the sensor's like.
I was looking for that, like an explanation of the actual sending part, and they do kind of skip over that. But there could be like some little turbine or something down there.
I bet it's powered with a big Chongqing battery. Maybe it's a turbine.
Maybe. I mean, if you've got working fluid, it could be spinning off of that. Well, I mean, in any case, it's certainly its own little island, right? Whatever it's doing, it has to get its own power and send its own stuff. It's not physically connected, and that kind of made me think of one of the ideas for like a Venus probe, was because it's so ridiculously hot and the high pressure that you would send like an analog kind of thing that would, based on the temperature, it would like flap a reflector, and then you would use radar to see that. You know what I mean? So you'd be able to get sensor data from the surface, but there would be no electronic components. It would be all this like mechanical analog stuff that would be able to survive. And it just made me think of that, where like you're trying to get data from an incredibly hostile environment with no traditional link, and you kind of have to think outside of the box.
But what I love about it is that a number of people in the comments, of course, have worked in the oil and gas drilling industry. And, comments range from mud butts. I cannot express how hilarious it is to have a single bit per second data transfer rate with 2024 tech, but that is the reality on some nightmare wells. He's like, if you could make a pulsar that worked reliably, even at 1K per second, you'd be able to print money. And I guess he's right, Oh, look at that. There you go. Another interesting bit of this tech is the tools strive to get the sensors as close to the drill bit as possible. Some of the designs are working to push the temperature ratings of equipment to 200 degrees C, including the mud pulsars. The batteries for these devices are designed for extreme heat and don't work at all, even at room temperature. What?
Oh, wow.
Yeah, so totally crazy. And of course he's right. Like the oil and gas drilling industry is trillions and trillions of dollars, right? And it's super important for them to get good data about what's going on way down at the drill head. So this does have to be one of those things where, if you could actually double or triple the data rate they'd get out, it would actually be worth tons and tons and tons of money. And it's pretty funny that a number of people in the comments worked in the oil and gas drilling industry and worked at these holes and all came up with this, and everybody's like confirming this to be a super difficult problem and B, a really interesting problem domain. So really, really cool. I have to say, 19 years of reading Hackaday, how have I never heard of mud pulse transmission?
All right, now I picked this next one because it caused quite a bit of debate over the weekend, but also it's something that I've kind of looked into personally, so I found it fascinating. This is gas-tight FDM 3D printing is within your grasp. And I gotta say, perhaps if Jenny hadn't picked that particular title, because if you are making 3D printed little pressure tanks, you probably shouldn't be holding them. Like, they should not be within your grasp. They should be safely separated from your personage, because obviously there's a high likelihood that they're going to delaminate and explode, right? So this is a whole experimental thing that the person's name is German Engineer. At first I thought that was like a placeholder, but apparently that is that is the name, German Engineer. And they wanted to 3D print little propane tanks for reasons that we won't worry about. But when the propane is liquefied, it's between like 150 and 200 psi, which is considerable. And when attempting to 3D print a little tank for it, just forget about it. Like, there's no way. It just permeates through the layers. Like I said, I've tried to do something similar with like compressed air, and it just doesn't work. That's not what 3D printing, desktop 3D printing, is designed for, right? But what this person found is that they were able to seal the print. In this case, was able to create a gas tight little tank that successfully held the pressure. Even though Jenny very clearly said in there that this is probably something you shouldn't take lightly, it was like the topic of the day on the comments was everybody saying like, oh, this is crazy, and you're basically making a grenade, and never do this, and all that kind of stuff. I mean, I don't disagree. I would probably, I would say I would definitely never put 200 psi into a 3D printed tank, but I do think there's, the technique of sealing the print to the point that it can hold pressure, I think is interesting. And there's certainly, lower pressure applications that are less explodey that I think, like I was saying, my thing that I wanted to try to do compressed air for like a horn that I was thinking about doing something with, and it would not need to be that kind of pressure, right? So I think that the idea has merit, mainly because you can make these bespoke tanks that could be, fit into whatever shape is necessary for your project. If you had something that needed a little bit of pressurized something, to be able to do like a conformal tank is pretty interesting. But yeah, it's definitely you need to be very cautious with this kind of thing for obvious reasons, and kind of keep in mind that you're well outside of the intended use for 3D printed plastics.
Is he doing this for propane or just for...
Yeah, specifically for propane, and I'm not 100% sure why. So it's a really double whammy where he has a pressurized gas that may explode and also happens to be hugely flammable.
Because part of me wouldn't hesitate to do this with pressure air or pressure water if you had tested it enough beforehand. What I mean by that is you do what they do when they test metal pressure tanks. You fill it with water, you put it up to that pressure, and you make sure it doesn't explode. And then you put it up to twice that pressure and you make sure it doesn't explode. Then you can be pretty sure that it won't explode at the rated pressure. Ironically, you don't fill it with air at that pressure because the air wants to keep expanding and it makes it into a very dangerous little bomb. Water is non-compressible. It doesn't store any energy. It just pressures the tank up. So there are totally safe and reasonable hobbyist ways to test these pressure tanks. But man, I don't know anything about propane, but it wouldn't surprise me if it were a solvent that worked on plastic. And so
Oh yeah,
this
that seems reasonable. You know,
he's coating it with something called dichtal, and I mean they must tell you what it's resistant to, et cetera, but I don't know.
and it's too. Somebody points out in the comments that the whole phase change thing with the propane makes it extremely cold too. So not only do you have whatever dissolving properties the propane probably has to begin with on the plastic, now it's cold. So it's like really just daring this plastic to blow up in your face.
Brittled. Eesh.
I should say for anybody who's just listening that, like, when we say tank, I mean the things he's making are very tiny, so it's not like he's trying to put this thing on a barbecue grill or something. I mean these things are like golf ball sized. I mean they're super small volume. Again, not saying I mean there's still plenty of danger to be had here, but I mean I think it is important to say we're not talking about a 15-pound tank of propane like you'd get for your grill. I mean this is a much smaller thing.
I would be really sure to dot the I's and cross the T's on this one before making even tiny little bombs like these.
Remember, folks, even the tiny bombs you need to be careful of.
See what we got there. 2, 5, 6, 8.
Man, I'm looking at the sheet for it. It doesn't really mention.
There we go. Your advantages: efficient use of materials, drinking water approved, gas and liquid tight components, high chemical resistance, including oil, improved UV resistance. I mean, it may be.
They got a phone number. It says they'll be happy to answer any questions. We should do a live call.
Call them right up.
Yeah, you ask them in German, like, hey, if I wanted to make some small propane tanks.
I mean, if this stuff is resistant to propane, then maybe? Oh, God, I'm so scared. None for me. Good luck, Louis Marks.
Yeah, probably don't do this one at home.
Well, from totally sketchy 3D printing to completely normal, entirely sane 3D printing, How To Mechatronics has a video studying the finer points of 3D printed gears. And here he's going through how noisy they are, how efficient they are, how easy they are to put together, how much backlash they have, and then in the end, kind of how strong you can make a gear train out of 3D printed gears. And he's looking at the three main contenders, which are kind of flat gears, helical gears, and herringbone gears. And if you've never seen the kind of two weirder types, flat gears are what you normally think of as gears. Helical gears, the gears themselves, the gear teeth themselves are cut on an angle. And then herringbone, of course, is cut in a V shape so that they angle in from both sides. The advantage of helical and herringbone should be that they have less backlash than flat gears because instead of the teeth mating in one plane, they actually mate across the slant or the double slant in the case of the herringbone, and that should help with the backlash. Conversely, the more complicated gears should also have a little more friction, should be a little bit less efficient, and that's one of the things he actually tests here. Not entirely surprisingly, he does get that result. What's interesting to me is that the flat gears run the loudest, and I guess that's because they don't have a continuous surface of pressure on each other, whereas the helical and herringbone gears run quieter. But then what he does is he runs them at a certain speed and figures out how much power he has to put in to have it run at that speed, and that's kind of a measure of how efficient they are. And he, of course, also gets the expected result there that the flat gears are the most efficient. What I thought was really weird here is that although when he does his backlash test and he finds that, as you'd expect, the flat gears are the worst, the helical gears are the best, I would have expected the herringbone gears to do at least as well. Maybe his V angle isn't steep enough or something. When he repeats this with a 4-gear gear train, he actually gets a lot less backlash on the flat gears than he does on the helicals. And I think that must be due to some kind of precision in manufacture or something. I don't know. I mean, these are all 3D printed, so it must be some kind of difference across the gears in that way. I really can't explain that result. The thing that I think ends up being a totally useful take home if you end up having to do your own gear train is when he's doing the strength tests, the wider and bigger the teeth on the gear are, especially with 3D printed ones, the stronger they are in general. And so there's kind of a ratio of the tooth width to the diameter of the gear that's called the modulus. And so if you are picking gears for this, design your gears to have fewer, bigger teeth, and they'll be stronger. And more infill if you need it, more perimeters if you don't want to change the whole infill. But that's kind of the big take home on this for me. You will never, ever get me to give up my herringbone gears, though.
Yeah, I knew you were going to go for this one. You are a confirmed herringbone aficionado. And I think that is his end conclusion, right? Is that if you're going to be printing them, you might as well just print the herringbone because they are uniquely suited for 3D printing because of the shape, and it turns out, hey, they actually work pretty well. Which I don't think is any great surprise. I remember some of the old school 3D printers had like the big printed herringbone gear for the extruder. As long as we've been squirting plastic out on desktops, the herringbone gear has been a part of it, right?
And that's because when you have to do those retracts, the lower backlash there makes them respond better. I have an Wade's herringbone gear extruder on my old Prusa 2 printer, which has got to be like 12 years old at this point.
But no, it's always cool to see, some real data to back it up. And some of these things we just take for granted, right? They were granted and maybe not know why. And so I did appreciate this one. I also thought it was, like when it goes into stuff like the noise that they make, it's not something I normally kind of consider, right? Just interested to see like the causes of the actual gear noise and how they mesh together and why that might be. If you need something that needs to be quiet for whatever reason, that's the design of the gear can impact that. And it wasn't something that immediately comes to mind when I think about designing gears, is how to, reduce noise. The more gradual engagement, he says, with the helicals and stuff, instead of just smashing into each other full force, when both faces hit each other simultaneously, you have this kind of gradual thing. He says it's not only smoother, but you can just hear it. You can hear that it's quieter. So if you were looking to have something that's sitting next to you and needs to be operating without disturbing you, that's an interesting takeaway, that using a more angled gear face can make it quieter.
And not entirely irrelevant, in the end, he wants to do a wear test, and he runs these for an hour or two and doesn't see any change in his first sample. And he's like, this is too loud. I can't run these. He's got a weight on the end of one of these arms, and he's running it at high speed, hoping to wear the gears out, and doesn't wear them out within an hour and gives up because it's just too noisy in his apartment. Bails out on that one, and so we don't get the results on that one at all.
He also says that PLA seemed to work fine, whereas I kind of think of, I don't know, maybe because it's stuff like PETG is kind of gained popularity. I think of PLA as sort of the, if I'm printing like some little trinket or something, it's PLA. I don't really think of it as if I'm thinking like a practical functional print, I'm usually thinking of a more robust plastic. So it was interesting to see that even with like the bare minimum PLA, that any printer, no matter how janky it is, should be able to square out PLA, can still produce viable gears is a cool takeaway too. Like you don't need some ABS or something just to make a working gear, at least not at this scale. These are pretty chunky gears.
The other takeaway I got out of this, and this is one that kind of undoes some of the results, I guess, in a way. Like another takeaway that you can get out of this is that he had some gears printed in PLA, and then he had some gears printed in PLA that was an older PLA, and it was brittle and it broke at a different strength and stuff. And he had nylon, and he had nylon gears fail at a really low force, like lower than the PLA and lower than the PETG. And like you, I would expect the nylon gears to hold up better than the kind of, the pedestrian PLA, right? But I think that, I don't know if it was difficulty in printing nylon. Nylon's a bitch to print with.
It is.
I don't know if it absorbed water because it likes to do that too. I mean, I don't know what the reasons for this variation are, but it's worth noting that he had a bunch of variation across these different plastic types and from gear to gear even that he couldn't really explain and doesn't really make sense with kind of the theory and the fundamentals here. And so I think that's another, I mean, on one hand, that kind of clouds his scientific results a little bit. It puts a little more fuzz in there. But on the other hand, it's useful to know that if you're worried about printing these gears yourself and all you've got is PLA, just make the cleanest, bestest, thickest, most infilliest print you can, and that'll probably do it. Given variation across plastics and everything, if it really matters, you're just going to have to test it.
Well, to briefly pull us away from the trials and tribulations of 3D printed plastic, this one I want to talk about is ESP32 powered Crunchy makes beats on the go. I thought this was a really cool project, so much that I wrote it up when I saw it. I'm not necessarily musically inclined, but I thought it was really cool. This is just it's described as like a keychain form factor music making platform where it's, you know, it's an ESP32, it's a audio amplifier, it's some buttons and LEDs and not a whole lot else. It can be built with like off the shelf modules on a little perf board, or you could do a proper PCB. But regardless of how you get there, you have an array of, you know, 4x4 tactile buttons, and there's a little, you know, printable legend that shows what they all do, and they play different electronic sounds and instruments, and you can layer them and mix them, and I guess a tracker would be the proper term for this, sorta. Does a lot of stuff without requiring a lot of hardware, which I thought was really impressive. A lot of the heavy lifting is being done in the software, which is open source, and kind of, you know, the hardware here is, my interpretation of it is that it's a little bit free form, where there's a few different ways you can arrive at the end goal, and it's not super important how you put it together, so long as the key players are there. You know, so long as you got the ESP32 and you got the audio, the I2S audio chip that the code is written for, and you have enough buttons and LEDs, the rest kind of just takes care of itself. So there's room for interpretation in the hardware side of things to get this code running on it. There's a little demo video that, like I said, to me it sounds awesome. Maybe I don't have the trained ear necessary for this, necessary to pass judgment, but I was very impressed with the sounds it was making for how little hardware was involved. And I think just how cheaply and easily it can be put together is really interesting. I think it's very approachable. I could see this being something you could do at like a hacker con or something. Like it could be like a little workshop that people put these things together. You could do it even as like the badge for an event, honestly, and still have the per unit cost pretty low. This was just released right before we wrote about it. I think when I was writing the article, like the GitHub wasn't even like more than a day old. So cutting edge stuff, and I'm interested to see where it goes from here. I think it's a really cool little platform to play around with if you want to mess around with electronic music, but you don't want to spend big money for like a synthesizer or like real stuff, and you just want to say, hey, am I into this? Am I into pushing little buttons and making sounds? Like this is a cool way to get started.
This is super similar to like the Teenage Engineering Pocket Operator Rhythm one. Like they're like drum and bass sequencer machine. It's got like 16 buttons, so you can do the 16-step thing, and you just hit them when their time comes, and it plays and loops, and it looks like a total lot of fun. It's like a pocket operator, but it doesn't have a screen on it. And ooh, maybe that's the next thing for people to work on here. It's funny because I've heard a bunch of people talk about making a device like this, but never actually seen one show up. So I saw this and I'm like, oh, who did this finally? And I was stoked to see it done. This is, like you say, the GitHub is 3 days old, and the code commits, half of them say initial commit code is a bit unorganized but fully functional, which is totally my kind of commit message. So you know what you're getting here, folks. But like you, I really like that the hardware is kind of it's not anything special. It's entirely in flux. You could just totally take this, run with it, A, just wire up a couple modules, B, make a super simple PCB and do it that way. There's a million different ways to do this. And I think that's pretty cool because, of how accessible it's going to be. Maybe I would add some more blinking lights to it. I want a couple more. I want an LED per button, I think. But other than that, I can't think of anything I'd change on that side. So then it's all just software refinement. And I'm hoping that a bunch of other people help him in his project start sending him commits with some really cool either sounds or modes or whatever else. This could turn into something really fun. And I do like that the hardware side of the platform is just so accessible. It makes it easier for people to hack on the software side.
Yeah, I mean, I think there's a good chance a lot of people could build this with what they have laying around right now, like as they're listening to this. I mean, maybe the audio chip is, you might have to go out and get that. Although I'm fairly sure I have one or two of those. I think it's a pretty common like Adafruit audio module. This is sort of, boilerplate minimalist hardware. It could definitely stand to be like with a screen and more LEDs, but of course that could be, further variations. Like I like that you could still have this very basic thing, but then you could expand it if you wanted to, right? Just like you could get it done on a proper PCB, or you could just kind of dead bug it. If those kind of improvements could be made, without compromising the low bar of entry, I think that's cool too, right? Like you could have, if your board has a screen, then great, then it uses it. If not, it just, it just doesn't. You know what I mean? I think that would be cool to see that. You could get in the door with a very minimal hardware, and then if you want to add that screen, if you want to add more LEDs and that sort of thing.
All right, well, that was it. If you enjoyed us not talking about 3D printing for 10 seconds, that time is over, because here comes Thomas Senladerer. Can a toy 3D printer be made great? And a few videos ago, he was looking at a $75 3D printer, the Easy 3D. As he says, it's a toy 3D printer. It's a pretty crappy 3D printer, but it has some neat design features. One of them in particular is that the three movement axes are identical to each other, and they're just kind of stuck onto each other to give it movement in X, Y, Z. That's kind of this device's most obvious design feature, but it's also kind of its Achilles heel because none of them are particularly stiff. And in particular, they're based on kind of C-shaped sections of molded plastic. And although they're pretty stiff in two directions, they're not very torsionally stable, so you can twist them really easily. And this thing is a wobble bot because of it. And so that's the first thing he is trying to fix in this video by printing kind of a really neat insert that goes inside the C channel and makes it torsionally stiffer. He concludes that the motors are crap and adds better motors to it. Not much of a surprise there. And as Jenny points out in the article, this video is sponsored by a company that makes motor controllers. So he throws these BQ, what is it, Big Tree Tech Clipper motor driver and controller suite at it. And that's kind of funny to do. For those of you who aren't Clipper nerds, it moves the motion control over to a bigger computer, over to a full-fledged Linux computer rather than a tiny little microcontroller. And so it can do all sorts of real-time processing things like compensate for the way the frame wiggles and stuff. And so actually, if there's anything that Clipper would be best for, it's kind of a crappy little printer like this because, if the frame's wobbling, but you can compensate that out in software, that's a winner. It's interesting to see he actually gets incredibly fast speeds out of this thing in the end by stiffening it up and throwing good motors at it. On the other hand, it's a tiny little print bed, and there is kind of the square cube law where the smaller your printer is, the easier it is to make it stiffer. And at this size, I think you should be able to make a printer that's really, really, really fast. The size-speed relationship is taken super advantage of by the 100 printer. I'll throw the link for that in the show notes, which is a mostly 3D printed frame. And you'd think 3D printed frame, it's going to wobble like crazy. But again, it's printing on such a small scale that it can do outrageous speeds and accelerations. And, this is a stunt printer. It's designed to print a benchy, so a small print as fast as it possibly can. And everything else be damned. But it's really kind of cool. And if you want to see how far you could press this kind of make it stronger just simply by making it smaller, I think this is the way to go.
This is really interesting to me because if you kind of wind the clock back, there was this feeling that like the $100 3D printer was some goal that had to be hit for mass market adoption, right? Like it seemed like at the time, unless 3D printers could be as cheap as 2D paper printers, they'll never be in everybody's home, and they'll never be this transformative technology. And obviously that never happened for a lot of reasons, but I think the cost of the printer ended up not being nearly as much of a problem as the fact that these are just not meant for everybody's home. I think that in the early buzzword days where everybody will have a 3D printer and it's going to, hyper local manufacturing and all this stuff. You won't have to wait for things to be shipped to you. You'll just print them out overnight, and all the crazy hype that was surrounding the printers. And it's interesting to see that, now we can do it. We can make a sub $100 printer, but nobody wants it because we realize that was never actually the golden goose that we thought it was. And people are happy to pay not a whole lot more, maybe like $250. They're happy to pay that $250, $300 for a machine that is not made entirely of plastic and can function without these kind of systemic modifications. So it's an interesting kind of example of something that we waited so long for and then in the end didn't really want or need. It's one of those things where like the anticipation is better than the having it, right?
I just bought a $100 3D printer, and it's actually the second $100 3D printer I bought, and it's because of mass production and kind of cheap and cheesy mass production that I was able to do it. It's normally, like you say, a $260 printer, but they take returns and then they sell their returns unchecked to unsuspecting suckers for $100. Al Williams told me to do this, and I did it anyway, and it turned out to be fantastic. I picked up a printer that was, unchecked, returned to the manufacturer for $100, bolted it together, it worked straight out of the box. My son is the happiest son with a 3D printer in the world. And after watching this go jealously for 3-4 months now, I just ordered myself one last week. No lie, $100 3D printer coming to my door. And it's not even a piece of crap. It's a 1-year-old Creality, right? It's a $260 printer, but because I'm willing to take the risk on it requiring possibly some work on my part, $100, no problem. And it's like 100 times better than this $75 crappy printer with any kind of work done to it. But then again, I also agree with you, and we're at a point now where the price pressure on 3D printers isn't such a big deal. You can get a totally reasonable 3D printer for $200, $300. And I think there's just not much incentive to push the price lower. And I think the horrible trade-offs you have to make to push the price lower, like is evidenced here, it's just not worth doing, and you shouldn't buy one.
There was a time it was hype and buzz and all that where everyone was breathlessly reporting on the 3D printing. It was going to change the world. It was the Bitcoin crypto blockchain of its time for a while, right? That is not the case for many reasons. And it now has become a tool like any other, right? So now the 3D printer, I think that the reality has more than kicked in. And if you want one, you want a good one, and you're willing to spend a couple $100. And it's like just like a drill press or a table saw or something. Nobody's chasing the $99 table saw to put them in everybody's house because at the end of the day, not everybody needs a table saw, right? So it's made the transition from buzzword and hype to practical tool, and the market has kind of found a price people are comfortable with, and of course, if you could pay less, you would, but I think there's an understanding that like there's too many trade-offs, and the average person who wants to be able to print stuff at home is comfortable with paying $200 to $300 and getting something that works out of the box, and we've sort of hit equilibrium. Well, this last one has nothing to do with a 3D printer. I hope that you'll forgive us. It is fantastically impressive accomplishment. This is Baldur's Gate 3 comes to the TRS Model 100, and that is not as exaggerated as you might think. This is a demake of at least the beginning part of Baldur's Gate 3. I mean, it is a TRS-80, right? Like, you have to give it some leeway. This is created by Alex Bowen, and the project itself is really well documented, and it's all the sources out there. Should you want to fork it, Alex actually developed an engine that is flexible enough you can load your own levels and stuff into it, and then kind of forked that into the Baldur's Gate 3 demake, which is really cool. Instead of it making like this monolithic thing, it kind of has now set the stage for potentially other games to use it for the hot TRS-80 Model 100 gaming scene. For those in the audience who don't have a TRS-80 Model 100, probably roll back a little bit. This is Tandy's 1983, I think, foray into portable computing. I mean, it's been called like the first laptop sometimes, and I think there is some debate a little bit about who was first. I think not to get too lost in the weeds, I think Tandy licensed the design from a Japanese company or something that was already out, but whatever. It's a super early portable computer, one of the very first. Certainly one of the very first successful ones, and part of that was that it came, out of the box with like a basic interpreter and tools and stuff installed on it, so it was easy to make your own software and right on the machine. Alex actually did attempt to make this game with the built-in basic. If you see in the video, there's a little bit of talk about that. But it was just too limited to do something of this scale. Mentions like variable names can only have 2 characters or something. So you very quickly run out, if you're trying to make a game of this scale, you very quickly run out of variable names when they can only be 2 characters long. So the end result had to switch it over to doing it in assembly, and there's all kinds of crazy optimizations that had to be made to pull this off. It's obviously it's ASCII art. To do real graphics on a machine of this age would be pushing it, but it looks really impressive with the ASCII world off to the left, and then you have kind of like the text menus and stuff on to the right. There's also a neat trick where using Unicode characters in the source code lets you get like a visual preview of what the game will look like when it's running on the hardware, because the levels are made up of these basically strings of characters. So you can actually look at the strings of characters in the source code and see what what the game would look like running on it, because it's just printing out lines of effectively text, right? There's a lot of cool optimizations to make this even remotely possible, and one of the ones I really liked is, there was no way to put all like the text and stuff. Like I said, this is a attempt to recreate a Baldur's Gate 3, which is a modern RPG, and so there's a lot of text and story and stuff, and there was no way to just fit all that as is. So Alex came up with this routine with a Python script that ran through all the text in the game and identified repeating character patterns, and then mapped those to like a code that you could then piece together sentences and words with the code that corresponds to the character, if that makes sense. So instead of storing whole lines of text, you'd be storing these, strings of digits basically, and it would piece them together, which is a really cool way to save a lot of space, but it isn't, computationally complex or anything. It was relatively easy just to look up these strings when the text needs to get printed out. So a lot of cool stuff about, working on extremely low end hardware. The fact that it runs on the real, you could play it right now in an emulator, but if you have a Model 100 kicking around that you can run this right on the real hardware is super impressive. And I do actually have a Model 100 somewhere that I'm very tempted to break out and try this. And if anyone in the audience has one, I'd love to hear about how it goes for you, and how far you got playing this game.
All right, my first quick hack this week: from Nissan ICE pickup to BEV with Nissan Leaf Heart is the story of EV swap conversions, taking apart a normal pickup truck and reassembling it and converting it into a battery electric vehicle. If you are the kind of person who just clicks on the video, don't do that here. By all means, click on the first link, which goes into a long forum post about how this was done. That's where all the neat nitty gritty details are. And that's where kind of all the differences between a gas car and an electric car are hidden. And it's an incredibly interesting look at everything that's missing, everything that needed to be changed, everything that needed to be added in taking a crashed up Leaf and making it live again in a pickup truck body. Next up, Unkyu Lee business card challenge entry. Who do you love? This is his business card for a made up Dr. Love divorce attorney. It's a galvanic skin sensor love tester game, and he says he dreamt this up with his wife, and they had a good time making it. They've played it with other couples who have either gotten into fights or laughed themselves silly about it. So this is a lovely entry into the business card challenge for Dr. Love, divorce attorney. And a reminder that it's running for another couple weeks. If you've got a business card project out there, get it on in. And last up, AI kayak controller lets the paddle show the way by Braden Sunwald. This is the story of him building the controller for an electric kayak. And I think the electric kayak by itself is really cool. But the idea that you want to make it like an electric bike where you paddle with the kayak paddle and it just assists you on each stroke seems like a lot of fun. And so he's got a little module that sticks on the kayak paddle and it's got an accelerometer in it. A lot of the story here is about making it waterproof and solid, of course, because it's going in the water. But the rest here is about collecting data from the user so that he can later figure out how to best add some motor assist to this. He gets a lot of flack because he's going to use a neural network for it, but I don't think this is actually AI hype. I think this is actually a totally legitimate application of neural networks to figure out how much motor impulse to give based on accelerometer readings.
Well, my first quick hack is Donkey Kong Bongos Ditch the GameCube, Go Mobile. You may, but probably may not be aware that in the early 2000s, Nintendo released a bongo peripheral for their GameCube, along with a couple rhythm games that had you playing along in front of your television. The bongos have faded into obscurity, probably not surprisingly. But this particular hacker, BL3I, really wanted to bring them back to life and went through the trouble of coming up with a add-on that the bongos plug into. And the original bongos aren't modified in any way. Like, they are still intact for the bongo collectors out there. Like, it even still has the same controller cord. This is just like a box that clips onto it and has an Arduino to interpret the control signals coming from the bongos, because they looked like a regular GameCube controller to the console. It reads the control signals, plays wave samples off an SD card depending on what part of the bongos you hit, and has a battery and all this kind of stuff so you can go mobile. It's a really cool, I would say, almost like a preservation of this little-known accessory while still, keeping it intact and avoiding that the urge to just gut it and put a Raspberry Pi in it. So, kudos to keeping them in their original form while still being able to accomplish the goal of playing them without the console. All right, next up is Baffle the Normies with this binary thermometer. This is a really cool, simple project from Clovis Fritzen. And it is just a little Digispark AT-Tiny board, temperature sensor, and 6 LEDs. And the temperature value is displayed in binary on the LEDs. We've seen binary clocks plenty of times before, but it's a little bit harder to decode that in your head than the temperature. So if you're looking to get started on showing information in binary around the house, it might be good to start with a project like this where it's a little bit easier to digest and work your way up. And finally, OpenSCAD cranks out parametric CNC clamps. I'm not alone in my love of OpenSCAD. I know Elliot will agree with me. It is an awesome way to do parametric designs and make something where you can just plug in a couple of values and have the 3D model change without having to literally, redesign the model. It lends itself to projects like this where you can have a base clamp design and just plug in the length and the width and the height and the angle and all that kind of stuff and get a 3D file to print out. OSStat released this script that you can run locally on OpenSCAD, but it's also compatible with MakerWorld's online customizer, which is cool. I didn't actually know they had kind of dusted that off. That was like an old Thingiverse thing that I don't even know if it still works. But you'll be able to, create a custom design right in the browser and download an STL that's fit for printing. Some people would say, hey, I don't know that I want to hold down my CNC workpiece with 3D printed clamps. But to that, I would say, they're 3D printed clamps. You can just print more. Like, if one or two is a little sketchy, I'm sure a dozen will be able to get there.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I picked Dan Maloney's Scrapping the Local Loop by the Numbers. And this was started off as a thought experiment. If we're switching all of our telephone networks to fiber optic, what's going to happen with all of this buried copper? With the prices of copper going through the roof, maybe it's worth digging that up, or is it just too expensive to do so? Should we leave it in the ground? And so Dan's trying to ballpark that here and comes up with about 800,000 metric tons of copper in the telephone, whatever it is, the public switch telephone network. And again, that's just amazing if you think about that in terms of, it's stretched pretty thin in all those wires. But then again, think about a country the size of the US. There's a wire that goes to everybody's house. It's insane to think of the size of this system. So you add all that copper up and it ends up being, at today's rates, about $7 billion worth of copper. And now the question is that a lot? Is that a little? It's spread pretty thin if you think about it. And, that's a lot of digging to get it up. So Dan ballparks what else you could do with this copper wire, right? Say you took all this wire and you melted it down, reformed it into thicker wires, thinner wires, whatever. What could you do with it? And so he starts with, an electric vehicle has about 60 kilograms of copper in its windings. If you pulled all of the telephone network up, you'd be able to build 13 million cars. That's kind of cool. I mean, just the copper for the windings on 13 million cars. But 13 million cars is pretty good, except in 2021, people globally bought 80 million cars. So if you did this one time dig up all that copper, it wouldn't even really cover the number of cars produced in 1 year, much less in forever. So he tries to think about it in a different way, which is to wind it up into generators and use it in wind farms. And there he kind of gets a little bit of a bigger result. So if you wound it up into power generators, you could probably build 267,000 megawatts of online wind power, which is pretty cool. And so when you compare that number to how much it would take to completely decarbonize the world's economy using wind power alone, it ends up being about 0.05% of the amount you'd need. So again, drop in the bucket. And so that's what's weird here, is that somehow $7 billion worth of copper ends up on a global scale or on a national scale even just not being that much. And it's one of these weird, kind of paradoxes.
The scrap price of the metal might be $7 billion, but if it costs $10 billion to get it out of the ground, you've not exactly made yourself a profit, right? And I imagine you could do it for less than $10 billion, but still, it would be a ridiculous effort to pull it all out. like we said earlier, Dan always kind of brings the receipts for these technologies that are going on around you, and the copper network that is strung above and below us, is a great example, because he describes it as one of the contenders for largest machine ever built. But how much of us really think about the copper lines that we probably don't use anymore, because we now have fiber optic internet and cell phones, and it's just it's like a thing that's sitting up there, but still has that value because of the raw material. So it is kind of a unique. Usually when a technology kind of goes to the wayside, it's just like, that's it, because it's been replaced by something else. But this one has a material value that kind of makes it unique. And I appreciate that he did do it by the numbers, like the article says, and kind of breaks down how many things you could do and what the reality of it is. We need a lot of copper. Like, we need a lot of copper. And even if you could snap your fingers and get everything out of the ground and off the poles, and you had it in this big pile in front of you, that's nothing compared to what it would really take to get us where we need to be in terms of electrification of everything. Kind of a sobering thought that all that, like you said, all that effort and all the technology and the labor, the sweat equity to put all that stuff out there is still nowhere near what we would need to get where we're trying to go.
The amount of copper we're mining annually now makes this small amount that's actually locked up in the telephone network not look like all that much. And, Dan's baseline here is, how much copper do we need to completely electrify the economy? And that is daunting and terrifying. But then if you look at this as a fraction of kind of annual copper mining and copper production, it ends up not being all that much. And so maybe it doesn't make sense to pull it up. I don't know. Dan's conclusion is, it's money sitting there in the ground, and it probably will eventually be worth it to dig it all up. And he sent a link out where it points out that the mean time to starting up a copper mine is about 18 years. And so if you imagine we had a demand spike 5 years ago, 10 years ago, somewhere in the world there are copper mines ramping up to increase production to, offset future demands of electric motors and whatever. But they're not online yet, and aren't going to be online for another 10, 15 years, question mark.
All right, well, my pick, Displays We Love Hacking, DSI, from Aria. This is, it's it's an article about hacking DSI displays, but if you haven't poked around inside of, a modern smartphone or tablet, you might not realize that they are almost all using this technology. There is a little bit of like a embedded display port, but DSI is kind of like the standard for little high-res screens and consumer stuff. And learning to master that, in the maker and the hacker community, opens up an incredible world of displays on the secondhand or, replacement market that are dirt cheap thanks to the economies of scale. I mean, even look at like the official Raspberry Pi display. They want like $70 for this thing, and I don't even think it's 720. It's like 800 by 400, something ridiculous. And that's just kind of the price gouging that we suffer through. But Aria makes the point that the display used on the Nexus 7 tablet, which is fairly old at this point, but it's still a 1920 by 1200 display. You can get them for like $20. The trick is knowing how to talk to them, and that's where these kind of efforts come in that she describes in the article. Breaking down how the communication works, and these efforts from different hackers and hardware types to kind of crack the code on a lot of these things. Because the protocol itself is one thing, how the device talks to the screen, but you also need to know like the secret handshake, for lack of a better word, like the initialization routines that are display dependent, and sniffing that does require a little bit more than your $10 logic analyzer, right? Like there's a little bit more that goes into it, but it is still doable on the hobbyist level, and we're seeing it happen. So, being able to unlock these displays and use them in our own devices, whether it's through like a little adapter board, or you actually implement DSI right on your own device, is very, very compelling, and it's only going to get better as more of these screens are kind of reverse engineered. And listen, there's no shortage of tiny high resolution screens coming out for the foreseeable future, right? Everything from your watch to your thermostat to the billions of phones that get cranked out will have this kind of technology in it. So I mean, it's really a limitless playground for us to pull these displays out and use them for our own purposes. So half the article is that and what's gone into that, and a little bit about, it's not super deep dive into the protocol, but it gives you the Reader's Digest version, for lack of a better term. And then Aria goes into some interesting examples that we've seen, whether it was written up through Hackaday or just in the community of people taking these DSI displays and doing cool stuff with them and reverse engineering them. And we got stuff like Mike Harrison going back to 2013, trying to hack the iPod Nano screen. So that kind of gives you an idea too how long these things have been out there. Like, this isn't some recent innovation. I mean, the devices have been shipping with these displays for over a decade now. So give you an idea how many are out there waiting to be utilized. So it's just a really cool article about this technology and how it's becoming more accessible to hobbyists, which is always, always a win in my book.
Yeah, I think you got it right. This is the dominant display technology, and it's one that we should get working on. It's unfortunately, as Arya points out and you mentioned, it's MIPI. It's the MIPI Alliance DSI, whatever it is, display serial interface or something. And MIPI is super closed. You can get specs for this probably if you have $1 million and are willing to sign an NDA. But if you're me, you have to dig around into the shadier corners of the internet to find the relevant PDFs, which shouldn't stop you. The spec isn't exactly open, and confounding that, of course, all the different manufacturers have different negotiation, initialization, handshake sequences. And so what you get with people like Mike Harrison and Wenting Zhang, who did some really cool work on these, is basically you have to take the display you're interested in, look at it in the device it's installed in, and then sniff the lines and see what you can get. That's not trivial, because at least when the video data starts flowing, it's gigabytes per second on 4 different lanes or something. And so probably need a scope. It probably needs to be a fast scope, and you probably need to get clever with your triggering sequences to begin to even get a feel for what's going on here. And I think that's where this becomes challenging. And the other method Arya suggests, and I really like this one, is you find a screen for which there's already Linux support. You've already got the device driver written and it's open source. And so if you need to find out what the funny initialization sequences are, it's probably in the Linux driver source code. So just go look it up and you can find it out. And that's a lot easier than having to do the reverse engineering yourself. Of course, this means that, for every cell phone out there, somebody's going to have to do it at least once. But short of open documentation coming from every cell phone manufacturer, I think that's the world we're living in. I do like her kind of blueprint here for how to get started on this, even though it's kind of hard mode right now. I think some people in our audience and in our community are hard mode and are going to tackle this. And the benefits of one person tackling a particular screen, if it's shared, spread out to everybody else. So I don't think this is an impossible problem. And like you said, and like Arya said, I think the benefits of kind of cracking the DSI nut are so huge that it's something that would be worth putting the time into.
It's going to take a lot of legwork, realistically. I mean, short of somebody leaking these documents out, hint, hint, if if you're in a position to, maybe release some of this info for the betterment of the hardware hacking community, please feel free to do so. But short of that, it's just going to take a lot of research and documentation. And I don't think she mentions it, but I'm sure there's got to be some wiki out there that's building up a lot of this info too, so that people can contribute to it, or or maybe just the best thing is to get it working in mainline Linux, right? Because that's about as visible as an open source compendium of drivers as the world has ever seen. So if you get it working in there, that's the example other people can work from, right?
That sounds good to me. I like it. Store the information in the code. All right, that's the end of this week's Hackaday podcast. Thanks very much for listening. If you'd like to follow the links or leave us comments, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, write us tips@hackaday.com. And until next week,
keep on hacking. Oh,
yeah, that's what it feels like.
Oh.
Well, that is the sound of Tom Nardi with a head cold.
I'm not sure which way you're going with it. So
I'm not either.
I'd like to help, but
Signal processing.
I thought you were looking for something a little bit more specific than that. Still would love to find that. Well, I can't have made it up, but I guess I could have.
Don't get me started.